All right, what's up, chat? Yeah, today we're doing contains duplicates. So we're given an array, integer array nums, and return true if any value appears at least twice. Otherwise, we return false. So pretty straightforward. We have an array 1, 2, 3, 1, return true because we got two ones. We have 1, 2, 3, 4, return false because there's no dupes. And then here we have multiple dupes, so we return true. Okay. So obviously, first thing we can do, like our brute force solution, is if we look at this, we can just iterate through the array and then compare each index with every other index. So if we're looking at the first index, we search the rest of the array and see if we find the same number. And if we do, return true. It's like two for loops, one outer loop to iterate through the array, and then one inner loop to iterate through every other element. So we can start with that. So brute force O of n squared. So let's just say n is length of nums. Simplify the code a little bit. So we'll say for I in range of n minus 1, since we want to compare with the I plus 1 index to the end. And then we'll say for j in range of n, so to the end of the array. And we just say that if nums at I is equal to nums at j at any point, or sorry, this is actually going to iterate through the same. So you actually need to update this to I plus 1, right? So you're comparing every ith index with every I plus 1 to the end. Yes. Okay. There we go. Yes. Nums at I is equal to nums at j at any point, right? Then we know that there's a duplicate, so we can return true, otherwise return false. So this is our brute force. Should return true. Yep. False and true. Nice. And then our optimal solution, you could use your classic hash map here. So just basically have a hash map storing the counters of each value as the keys, and then the number of occurrences. So you'll have like 1:2, since there's two ones. And if at any point any of the values, the keys are greater than 1, then you know you have a duplicate. So hash map will be O of n. But a play on what we just did for the brute force, you can actually improve this slightly without using a hash map by just sorting the array, right? So if you imagine we take this example here. And let's say we sort it before doing anything. Okay. Right, so that would give us 1, 1, 2, 3. And then now since it's sorted, instead of having one outer loop where you compare every index with every other index to the end of the array, you can just, since it's sorted, you can just look at every ith index with every I plus 1 index. So you can say for I in range of length of nums minus 1, if nums at I is equal to nums at I plus 1, then you know you have a dupe. So you return true. Otherwise, you return false. Right? And why does this work? Because if you see here, you have 1 at your ith index, I equals 0. And then since it's sorted, if there is a duplicate, right, it's going to just be right adjacent to it at the I plus 1 index here. So that's how you know there's a dupe. And this is actually O of n log n, because this loop, sorting or looping through the array and checking, is O of n, but this sort here is O of n log n. And since O of n log n is greater, this is our runtime here. So I won't write the code out because it's just basically an extension of this, except you're just sorting first. So that's not the optimal solution, but I figured I mention it because it's another way to like subtly improve the runtime here. Okay, so we'll get it to our O of n solution now using a hash map. So I'm just going to define, let me comment this out. Just going to copy this. And we need to initialize our dictionary. I'll just call it counter. And the first thing we need to do here is populate our hash map with all of the numbers and their occurrences. So we'll say for num and nums, basically what we're going to do is if the number doesn't exist in the dictionary, we'll give its value 1, because that's the first time we see it. But if it does exist, then we'll increment its count. So in Java, you have a method. You can just do it get or default. I think it's just get in Python. Yes. So you can say that counter at num is equal to counter.get num, defaulted to 0 if it's not in our hash map, and increment its count to 1. Right, so we check if the number already exists in our hash map. If it doesn't, we default it to 0 plus 1. So we set its value to 1. Otherwise, if it does exist, we'll just increment its count by 1. So like that's just a simplified way of writing if num is not in our counter, then take counter at num and we set it to 1. Otherwise, we set the value and increment it by 1. So this is just equivalent of saying that for shorthand. Cool. So now we get our hash map. And then, so we have our hash map with all the numbers and the values. So really, if any of the keys in our hash map is greater than 1, then we know we have a duplicate. So we can just do a check for that. So we'll say for key value in counter.items, if the value is greater than 1, so it has more than 1 occurrence for any of the numbers, then we just immediately return true. We found a duplicate. Otherwise, we return false. Yes. Looks good to me. Nice. Runtime 0 ms, so really fast. O of n. This is our optimal solution. We can't really do any better than this. All right, so we have our brute force, just iterate through the array, basically like twice with the outer loop and then the inner loop comparing every other index. And then didn't write it here, but we also had our sorting solution, right? So we just sorted it before we iterated through the array. And the purpose of that is it'll be a little bit faster because we'll be improving it just to the time it takes to sort the array. And then we have our hash map solution lastly. So just storing a counter of key value pairs for each number in our array. And then this piece here, iterating through the array and populating a hash map is O of n. And then searching a hash map and it's just O of 1 time. So we can do this part in O of 1 time. That's why we get overall time complexity of O of n here. And then I did want to show like one other solution. This one's like a little more creative, but you can take advantage of using a set. So if you don't know, a set just dedupes all the values in an array. So we can use that because if we take this example here and we convert it to a set, we'll just get 1, 2, 3. So that one extra one would be dropped. And immediately we know if the set returned a length that's less than the length of the original array, that means we dropped a duplicate. So you can literally just do a check for that. So you could say, I don't know, call it deduped is equal to set. So we'll convert it to a set. And then you say that if the length of dedupe is different from the length of nums, then we return true. Otherwise, we can return false. And yes, okay. And the reason this is creative is because like you don't have to really write this code where you iterate through array or use a counter hash map. But this is still O of n, so we haven't really improved our time complexity, but it's just a more creative way of looking at it. Yeah, that's just because like converting to a set requires you look at every element in the array. So that's just O of n. And this is cool because in Python, you can actually just write it in one line. You could just say that if, yeah, comment this out. If the length of the set of nums is different from the length of nums, you just return that value. So this will evaluate to true when its length are different. Otherwise, it'll be false. Nice. So this one is probably not too important to remember, converting to a set. And probably not the solution that interviewer would be asking you about just because it's a little cheesy, just like converting it to set. What is more interesting here is the brute force method. So recognizing we can just solve this by iterating through the array twice, essentially. And then I think the most important solution is that optimal solution using a hash map. And this is a pretty common paradigm where you have a hash map, you restore counters. And then you can just search the hash map in O of 1 time. Yep, need to comment that out. Cool. Nice. I don't think there's anything else to say about this one.